All right, welcome back. My name is Ben Tankersley, and you're watching the CTRL+Strum Builder Series. This is where I document the process of building systems at the intersection of AI, automation, software architecture, and weird science. Today, we're continuing the Jarvis project, and this is mission log number 2. And in this episode, we're breaking down the architecture of the Jarvis control plane. This week, I watched a few interviews with some of the top AI researchers in the world. And honestly, some of the things that I learned were pretty unsettling. And not because anybody was talking about AI taking over the world, but because several of them said something that is easy to forget when you work with these systems every day. We understand how to build neural networks. We understand how to train them. We understand the mathematics behind gradient descent, backpropagation, transformer architectures, and all the machinery that powers modern AI. But once these systems reach a certain level of complexity, something interesting starts to happen. Their behavior becomes emergent, meaning that the system starts to learn patterns and reasoning strategies that were not explicitly programmed. And at that point, the internal reasoning process can start to look a lot like a black box. And what's fascinating is that it isn't just true for artificial systems. It's also true for biological neural networks. A couple years ago, researchers actually grew a small network of living brain cells in a dish and connected it to a computer interface. They trained those neurons to play Pong. The network learned how to move the paddle, it improved over time, and it adapted to feedback. But the researchers could not fully explain how the learning happened internally. The network just figured it out. And modern AI systems are surprisingly similar in that sense. We understand the architecture, we understand the training process, but once the system learns, the reasoning path inside the model can become difficult to interpret. Now combine that with the fact that people are building AI agents that can write code, deploy infrastructure, run workflows, interact with production systems, and suddenly the question isn't just, what can AI think? The question becomes, what should AI be allowed to do? And that is the problem that Jarvis is trying to solve. Jarvis isn't trying to control how AI thinks. Because if the intelligence layer is a black box, the execution layer probably shouldn't be. And that idea is what the entire Jarvis architecture is built around. So today, we're going to slow down and look at how the architecture actually works. The structure for this episode is simple. Plan, build, and debrief. And first, we start with the plan. Before we trigger anything inside the system, I want to zoom out and reiterate what Jarvis actually is. Jarvis is a control plane for AI actions, and it sits between the AI agent and the systems that the agent might want to interact with. And its job is to make sure that every action can be inspected, can be approved, can be executed safely, and can be reconstructed later. Architecturally, the system is built around 4 major layers: the agent layer, the governance layer, the execution layer, and the trace layer. And the easiest way to understand those layers is to follow a real proposal moving through the system. So instead of just talking about the architecture in the abstract, we're going to actually let the agent generate the proposal that drives the walkthrough. And while we do that, I'm going to keep a couple different views open on my screen. On the right side, you can see Jarvis HUD. On the left side, you can see the agent. And behind both of these screens, is the repository, which I will also occasionally reference. The first layer of the system is the agent layer. In this system, the AI agent I have named Alfred, and yes, I did steal that from Batman. Alfred runs through the OpenClaw framework and observes the environment. But Alfred cannot execute anything. He only proposes actions. But instead of me explaining Alfred, I'm going to let him introduce himself. I also thought that Alfred was deserving of an avatar, and I didn't really want to tell him who he was, so I asked him to choose his own avatar and create his own, and this is what he came up with, modeled after Alfred from Batman. I thought he did a great job, and he said he was satisfied with it, so we're going to let him keep it. And without further ado, I'm going to ask Alfred to introduce himself. Okay, Alfred, why don't you tell us a little bit about yourself? Alfred here, Embedded Ops Steward for CTRL+Strum and the Jarvis control plane. I keep the system aligned, surface leverage, and stay hands-on with whatever execution bin needs. How can I help you right now? That's what I'm talking about. That is AI agent service right there. And now we're going to ask Alfred for a proposal that we can follow through the system. Okay, had a small little runtime error, but no big deal. I just had to restart OpenClaw really quick, and we're right back at it. And as you can see, Alfred has proposed a safe demo action, Jarvis control plane, telemetry walkthrough, and we're going to say go ahead and push this to Jarvis. And you should be able to see the proposal come through in real time on Jarvis HUD. And there it is. Proposal submitted. And let's go check that out. But before we check out that proposal, I just wanted to go ahead and show you where this boundary lives in the code base and what boundary is implemented here. It's called the ingress boundary. And in the code base, this file is going to live in source, app, API, and ingress route.ts. Once the proposal enters Jarvis, it moves into the governance layer, and this is where the system decides whether the action is allowed to proceed. And there are three big parts here: authentication, approval, and policy. And then the final part of this governance layer that I've set up is a thesis lock. So even if Alfred proposes the perfect action, the proposal still has to pass through the governance before anything can happen. If the action passes governance, it moves into the execution layer. The path is implemented at source, app, API, execute, approval ID, route.ts. That is where Jarvis evaluates the policy gate one more time, runs the appropriate adapter, and generates a receipt. And now the moment we've all been waiting for, we're going to follow this all the way through Jarvis HUD now. I'm going to go ahead and approve it. And I went ahead and executed the proposal. And this whole trace, once again, the agent layer proposes, the governance layer evaluates, the execution layer performs, and the trace layer records everything. And that will conclude mission number 2 for Jarvis HUD Builder Series. And I thought it might be appropriate for me to give Alfred the authority to tell you all good night and let you know what's coming up in the videos. I would love for you to like and subscribe if you're interested in this kind of thing. And so would Alfred. And let's see what he's got to say.